Welcome to the chemistry lecture series, lesson number 3. So in this session, we are basically looking at uncertainty in measurements. So just from looking at the base units, which we will be using. So now, for example, you take you're measuring something, right? So let's take, for example, you are measuring some volume of a substance. So your volume is equal to, let's say you measured as 15.234. Maybe these are cubic centimeters. So now the question is, we need to know which are the units we should consider in this measurement. So that's why we say in any measurement you take, all measurements have a degree of uncertainty regardless of the precision and accuracy. No matter how you think you're accurate, there's always something that is not certain. So this is caused by two factors. That is the limitation of the measuring instrument. It could be that the measuring instrument has a problem, which is called the systematic error, if the instrument you're using has a problem, and the skill of the experimenter making the measurements to call a random error. So if it's an instrument, we say it's a systematic error. But if it's you, because you are human, you're prone to error because maybe eyesight, maybe you are shaking when you're taking the measurement, and you cannot really be certain, we call it a random error. So for example, in this measurement, we have got degrees. So when someone was measuring here, that is the temperature. As you can see here, there's a 25 degrees Celsius, which is clearly calibrated, and there's also a 30 degrees Celsius, clearly calibrated. And then here, it says the estimate, the second digit in 27 is estimated and therefore uncertain. So for example, if this person says, this measurement is 27 degrees Celsius, well, because it's not calibrated, you can say there's some degree of uncertainty there. So we'll learn more when it comes to how to handle those uncertainties, that is when it comes to significant figures. For now, let's learn something about these things. So the first thing we'll learn is that accuracy and precision. What are the key points we should take? So when you're taking a measurement and we say that you're accurate, it refers to how closely the measured value of a quantity corresponds to its true value. Okay, then precision expresses the degree of reproducibility or agreement between repeated measurements. So I'll explain this as we at the next slide. So the more measurements you make, the better the precision, the smaller the error will be. So precision is how consistent results are when measurements are repeated. Precise values differ from each other because of random error, which is a form of observational error. Now let's look at this diagram to understand precision and accuracy in detail. So you can see that the black dots there, this is like a game of darts. So you can see the black dots there. So these units, so what it is that the bigger red value there, the red dot, that's our true value. We want you to hit that one. But the black dots there represents the values we have been getting from the measurement. So because the black dots are so close to each other and they are also close to the red dot, we say, oh, these measurements are, you can see there, are accurate but not precise. Well, for me, oh yeah, anyway, we can say they're not so close to each other, but they are close to the red dot. Okay, each one of the black dots is close to the red dot, meaning that these guys are accurate but not precise. Then in this diagram, as you can see, these dots are far away from the red dot. At the same time, they are far away from each other, meaning that this measurement is neither accurate nor precise. Then for this one here, as you can see, the black dots are clustered where there is the red dot, which is our true value. So we can say this one is accurate and precise. And then this one here, our red dot is our true value, while the black ones are our measurements. So they are far away from the true value, meaning that these ones are not accurate, but they are precise. So in summary, what we can say is that if you have got, let's say, your true value when you're taking measurements is 25 centimeters, 0.00. And then you measure for the first one your trials, we call these trials. So your first trial you get 24.9, then maybe 9.2. The other trial, this is trial number 1, trial number 2, you get 24.96. Trial number 3, you get 24.97. So we can say because these guys are so close to 25, so these measurements are accurate because they are close to 25. Then when you look at these measurements at the same time, what is happening is that they are also close to each other. So meaning that these measurements are also precise, right? But a situation where they are far away, let's say for example we had 19.8, then we have got 5.6, then we have got 10.7. These are not accurate and they're not precise because our true value is 25. So they're not accurate and they're not precise because precise deals with the way they are. Are they close to each other? If they're not close to each other, they're not precise. Then if you look at these measurements, are they close to this one? If they're not, then they're not accurate. So